Hi, this is question 7 from the AQA Core 1 January 2012 exam paper. For the first part of this video, I'd like you to see if you can try the question for yourself. So if you'd like to pause the video and give it a go now. Okay, well done if you managed to have a go. For the next part of the video, I'm going to go through some hints as to how you can go about answering the question. So I'm just going to make this a little bit smaller. We've got more room. Okay, so we've got a circle that has got a centre C and has this equation here. And we want to express this equation in this form. So in order to do that, what we would need to do is we need to first of all take our x terms, and we want to complete the square on our x term, which will be that one there and that one there. And then we also want to complete the square on our y terms, which will be that one there and that one there. And once we've done that, we should be able to rearrange it to look like this here. Okay, part B. We want to write down the coordinates of C. So you want to think about how your circle will have been translated, and this equation here will give you the clues. Similarly with the second part, we want to write down the radius of the circle, and again we want to use this equation to tell us what the radius is going to be. Okay, part C asks us to sketch a circle, so hopefully from part B we'll have enough information, because we'll know the coordinates of the centre and we know the radius of the circle. We should be able to do that without any problems. Part D, we've got a line that has got this equation here where k is a constant, and we want to show that the x coordinates of any points of intersection of the line and the circle satisfy this equation here. So if we look at the equation that we formed over here, what we want to do is we want to replace because we're solving these equations simultaneously, we want to replace our y with kx plus 6. We then want to expand it and rearrange it so that it looks like this here. So we've got it in the form ax squared plus bx plus c. Okay, for the second part of this, we're asked to show that the equation, or we're told that this equation has got equal roots, so we want to show that we can turn that information into this equation here. Now we know what the values of a, b and c are, and we need to remember that if it has equal roots, then b squared take away 4ac must be equal to 0. So using that information, we should be able to get it into that form there. Part 3 says, hence find the values of k for which the line is a tangent to the circle. So we want to decide what this part of the question has told us and how that relates to this here. Okay, what I'd like you to do now is pause the video and see if you can have a go at finishing off this question. Right, the next part of the video I'm going to go over the answer of the question. So for part A, we wanted to express this equation in this form, so I said we're going to take each of these parts separately. So if I completed the square on x squared plus 14x, well, that's going to be x plus 7 squared subtract 49. I'm also going to complete the square on y squared, take away 10y, So that's going to be y subtract 5 squared by 25. Okay, and then I've also got this plus 49 term on the end, and that's equal to 0. So this bit here is there, and the green bits here is there, and we've still got the plus 49 equals 0. Okay, and we can now simplify this. Well, that subtract 49 and that plus 49 are going to cancel each other out, and this subtract 25 I can move on to the right hand side of my equation. So if I want to write it in this form, I would say that x plus 7 squared plus and that's going to be equal to, and remember I've added 25 to both sides, so this 25 will appear on the right hand side, but I'm going to write it in this form here. So instead of writing 25, I'm going to write 5 squared. And there you go, that's part A done. Part B, for the first part of part B, we need to write down the coordinates of C. So I like to think about how this is translated from the origin. So if I had a circle as x squared plus y squared, then the x will have been replaced with x plus 7. So that tells me that it's a translation of -7. And y would have been replaced with y take away 5, so that would tell me that it's a translation in the y direction of 5, positive 5. So that means my coordinates from 0, 0 will have gone to -7 and 5. So that's where the centre of the circle is now going to be. Part 2, we want to find the radius of the circle, and the radius of the circle is given by the r value here, which is going to be 5. Okay, and then part C, so I'm just going to come over here. Okay, for part C we want to sketch the circle. So okay, and I'm just going to draw myself a set of axes over here. And our circle has got a centre of a -7 and 5, so that's where the centre of our circle is going to be, and it's also got a radius of 5. So what we need to make sure that we do is the radius, because it's got a radius of 5, it's only going to touch our x-axis. So we need to draw our circle and show that it touches our x-axis. And what I would actually also do is I would just mark -7 there, and it may also be useful to say what the coordinates of the centre of our circle is. Let's just see if I can make that a bit clearer. That's the centre of the circle. Okay, and there you go for part C. Okay, and I'm just going to move part C up here to give myself a little bit more room for part D. Okay, Right, so for part D, we've got a line that has got equation y equals kx plus 6, where k is a constant. For the first part, we need to show that the x coordinates of any points of intersection of the line satisfy this equation here. So I'm first of all going to substitute y is equal to kx plus 6 into this here. So I've still got x plus 7 squared, and I've got plus, and instead of y subtract 5, I'm going to have kx plus 6 subtract 5, and kx plus 6 subtract 5 is just going to be kx plus 1. So I'm going to have kx plus 1 squared is equal to 5 squared. Okay, so I'm now going to expand this out. It might be useful for you to pause the video and do this part yourself, but I'm just going to write down that this bit here will be x squared plus 14x plus 49, and this bit here is going to be k squared x squared plus 2kx plus 1 equals, and I'm going to write that now as 25. Okay, and if I tidy this up, and again it might be useful for you to pause the video and try this bit yourself, but I've got an x squared term there and a k squared x squared term there, so I know that that's going to be k squared plus 1 lots of a squared, and then I've got, if I look at my x terms, I've got 14x plus 2kx, so that's going to be plus, and I've got 2x as a common factor of this, but I'm going to write it in the same form they've got it there, so that's going to be 2 times k plus 7 x, and I've also got a plus 49 and a plus 1 there, which is going to be plus 50 equals 25. I'm now going to subtract 25 from both sides, so that's going to tell me that I've got k squared plus 1 x squared plus 2 k plus 7 x plus 25 equals 0, which is what we've got over here. Okay, for the second part of this, I want to show that this equation here, sorry, I'm being told that this equation here has equal roots, and I want to show that we can write this equation here. So the key thing here is that it has equal roots, and we said that that tells us that b squared subtract 4ac has got to be equal to 0. So I'm just going to start by writing down what my values of a, b and c are. So a is going to be, well, it's going to be, I'll use it here, k squared plus 1, and it's the coefficient of my x squared. My b value is going to be the coefficient of my x, which is 2k plus 7, and my c term is going to be 25. Okay, and I want to show that b squared subtract 4ac is going to be equal to 0. Okay, so well, b squared is going to be this term squared, which is 4k plus 7 squared. Yes, so I've just done the 2 squared, which is 4, and the k plus 7 squared. Subtract, and we're going to have 4 times a, which is k squared plus 1, times 25, c, which is 25. And we want that to equal 0. So if I expand this out, I'm going to have 4, and that's going to be k squared plus 14k plus 49. Subtract, well, 4 times 25 is 100, so we're going to have 100 k squared plus 1. Multiplying all of this out, I've got 4k squared plus 56k plus 196, subtract 100k squared, subtract 100 equals 0. And if I rearrange all of this, that's going to give me negative 96k squared plus 56k and plus 96 equals 0. And we're almost there. What I'm now going to do is, to get it into this form here, is I'm going to divide everything by a negative 8. So if I divide this by negative 8, I get 12k squared, and then that's going to be subtract 7k, subtract 12 equals 0. And there you go, we've got it in the form that we want it. So if this equation has equal roots, then this here would need to be true. Okay, finally part 3, and I'm just going to tidy up my work a little bit. Okay, for part 3, the question says, hence find the values of k for which lies in this equation here. And if I factorize it, in fact I get 4k plus 3 and 3k subtract 4 is equal to 0. Okay, so I want to find the values of k for which this is going to be true. So either 4k plus 3 is going to be equal to 0, or 3k subtract 4 is going to be equal to 0. So if I solve this one for k, 4k equals negative 3, which means k is going to be equal to negative 3/4. And for this one here, I've got 3k equals 4, which means k is going to be equal to 4/3. And there you go. So those are my two solutions for k. And in case you're wondering, I'm going to quickly explain why there are two solutions. Now, we found the values of k for which the line is a tangent to the circle, and the k came from this equation here, which is the equation of our line. So in fact, we've found two lines. We've got y is equal to negative 3/4 x plus 6, and we've also got the line y is equal to, and the other k value, which is 4/3 x plus 6. So what we've actually found are two different tangents to the circle. One of them is going to be this one here, and it's going to be a gradient that's going to be negative 3/4, and it goes through y-axis at 6. And we've also got a different tangent to the circle where the gradient is going to be 4/3, and it goes through this value of 6, and it's going to look like that there. And that's basically why we ended up getting two values of k, because there's actually two possibilities for this tangent. Right, okay, I hope you found that useful. Thanks very much for joining me, and I look forward to seeing you again soon.